The webinar you have entered as an attendee in listen-only mode.
Hello everyone, a very good evening. Bhaskar this side. I hope you guys are doing good. Can you quickly just confirm me if you can hear me and see my screen as well? Okay, thanks, Ashmita. Okay, guys, so let's wait for a couple of minutes and we're going to start. Okay, guys, so let's start with today's session. So, first we're going to revise what we have learned yesterday. So, yesterday we have, inside the networking and content delivery module, we have checked what are the different kind of a security VPC security components. Like, we have the security groups and your NACLs. After that, we have, then we have learned about the Route 53, which is a domain name service, okay, system, domain name system service. So that was, and then we have completed that lab, okay. And so let's first let me take few questions, and then we're going to start. Okay, so can we have deny rules inside security groups? Yes or no? Can we have deny rules inside security group? Very good, guys. What about others? Only three answers till now. Raghavind, Durga, Srikant. Okay, so the correct answer is no, we cannot have. Okay, so security groups works at what level? Security groups works at what level? Very good, Raghavind. It works at instance level. And what about NACLs? NACLs works at what level? Very good. So NACLs works at subnet level. Okay. So what are the different Route 53 policies, guys? Seeing all the policies. What are the different Route 53 policies? What are the different Route 53 policies? I'll wait for a few more seconds. I got few answers. Vivek, stateful and stateless is not the Route 53 policy. Stateful and stateless are the, these are related to the security groups and your NACLs. I was talking about Route 53 policies. Yeah, I got multiple answers, and yeah, most of you are right. So we have simple routing policy, then we have the weighted round robin routing policy, then we have latency based routing policy, geolocation, geo proximity, failover routing policy, and finally we have our multi-value answer routing policies. Okay. So in the case of disaster recovery, which routing policy will work? Which Route 53 routing policy you are going to use for disaster recovery scenario? Very good, guys. Hmm. The correct answer is failover routing policy. Failover routing policy. Okay. Anything else left? Mm-hmm. Okay. Which routing policy helps us to improve the application performance? Which Route 53 routing policy helps to improve the application performance? Very good, Sandeep. Hmm. Great answer is. Any other answers? I've got two answers, around 5 to 6. The correct answer is latency based routing policy. Because with the help of latency based routing policy, user is going to connect with the connect with the application using the request will go to the nearest AWS sources. Okay, I think I've covered all the questions, so that was it for the question part. And I believe you would have completed the activity, the VPC activity and the VPC lab. So has anyone completed both quickly? Yes or no? Okay, great, Ravin. Okay. What about others? Money? Where is money? Hmm. Okay, so first we're going to complete this another topic, that is CloudFront, and then we're going to go through that activity, and finally we're going to complete the lab, and then we will proceed to another module. Not lab 1, Nikhil. Lab 1 was I'm talking about lab 2, VPC, which I've given it as a homework. If not, guys, please take this seriously. It will help you, not me. So please do these things, okay, on the time. Money, that is actually, I don't believe in the excuses, okay. So please don't give me any excuse. Please try to do these things on time. Yeah, please, guys, okay. So, but we are going to discuss that. So please concentrate, but try to do the labs on time whenever I'm giving you the homework. Okay, guys, so let's start with this section, okay, that is CloudFront. Then we are going to move to the lab part. Okay, so this is the last section of our networking and content, delivery. So CloudFront is it is a content delivery network service, okay. So first of all, let's see what is this content delivery and network latency. So this content delivery and okay, activity Durga. Let me complete this topic, okay. Then we will see the activity and lab. Okay, I've already told to the class. Okay, so suppose how the request goes to the origin server, guys. Suppose you are here, you are the user. Suppose this is Durga, and Durga is trying to access Amazon.com from his client machine, and this is the origin server where Amazon.com is hosted. So how the request will go? Suppose Durga wants to check the new pair of shoes from Nike. So Durga is going to search for a new pair of shoes of Nike, any model or random Nike shoe search. Then that request will go to nearest router. From nearest router, it is going to hop to another router. What is hopping? Hopping means when a network signal, jumps from one router to another router. That is the meaning of hopping. It is a, hopping is a, it's a process to send a request between two routers. So from one router, the request will hop to another router, and it is going to travel a multiple path, because the path is not the path is not defined. So it is going to check out all the path, and then with multiple hop it is going to reach the origin server, and the same way the response will be sent from origin server to the client machine. This is the whole process of request and request and response. So in this, okay, multiple hopping takes place. The router is hopping the request to another routing. So in this, it the latency occurs. This process takes little bit time. It consumes little bit time, and because of that, a little latency occurs in the network, in the public network. So this is the meaning of latency. So to remove this, okay, so to come over this problem, we have the CloudFront service which uses the advantage of edge locations so that they can deliver the content to the global users without any latency. You got it now how the latency occurs? With the help of this hopping process, hopping the request from multiple routers to another routers, this latency occurs. Okay, latency will add. Latency means you will get the response from the website in after some time, not the instance response. So to come over this problem, to come over this challenge, we have one service which is known as CloudFront service, which is a content delivery and network service. And the meaning of the content delivery and network is that this particular CloudFront service uses edge locations and regional edge caches. Okay, and with the help of that, you can deliver the content, the website content to global users without any latency. So what is the CDN network first? It is a global distributed system of caching service. With the help of content delivery network, like they have, they have distributed, they have created a distributed system. AWS has created a distributed system, and the distributed system is created with the help of edge locations and regional edge caches. And what is happening inside edge locations and regional edge caches? We are caching the content. We already know what is caching. Okay, caches copies of commonly request files. Okay, so look at mainly static content. Though we can also, we can also cache dynamic content, but we think it is not much feasible. I'll tell you why. So we cache the copies of mostly commonly requested files. So whatever will be the frequently request, that will be cached inside your edge location. Delivers a local copy of the requested content from a nearby cache edge or point of presence. Yes. First of all, whenever the request, suppose Durga is requesting for the same Nike shoes to Amazon.com. So first of all, if the data is not there in the edge location, then the request will go to the origin server. From origin server, the response will first, that response will be cached inside the edge location. Then it will transfer to the Durga's client machine. And next time, suppose Ashmita is going to check the same product, then her request will be fulfilled by edge location, because edge location has that data. So it accelerates the delivery of dynamic content, though you can also use dynamic content, but why it is not feasible? Because dynamic content changes. Okay, suppose let me take an example of a share market application. Even within the seconds, the prices of the stocks get manipulated. They get modified. That is a dynamic content, which is the dynamic content means which is changing at the real time. And what is the static content? Which remains static, which remain permanent, not permanent, but it remains static. It won't move at the real time. So for dynamic content, the caching is not a good solution. Okay, why? Because suppose you are you have created a stock market application, and you are using caching to store the data. Okay, at the temporary data for some time inside the cache. Now what will happen? Suppose I am the person who is using your application, and now I will see, first of all, I will see the stock price of some particular stock. Then I will see the same price for some amount of time, because that data is cached. And at all the server, the data got modified because this data is dynamic. When the data is dynamic, we are not going to use the caching, because the data is going to change each and every second. And in this case, if suppose I am using your website, definitely I will go into the loss, because every second the price of the stock is getting changed, and I am not able to see the current stock price because I am seeing the stale data, because that cache data will be a stale data. So that's why we go for the static content, and definitely because static content we are not going to change, so that the static content will be delivered to all the global users without any latency. Okay, improves application performance and scaling. Definitely the application performance and scaling gets improved with the help of low latency, and the same number of requests are not flowing to the origin server. So these were the two advantages which I told you previously also as a CloudFront advantage. So ultimately it is improving the application performance. So now what is CloudFront? The same, let me repeat, fast, global and secure CDN service. It is a CDN service cloud, content delivery network service, which is used to deliver the content to global users without any latency. So it is using the global network of edge locations and regional edge caches. It is a self-service model. You have to configure this service from your end if you want to use the service, and it also has that basic pricing of AWS, that is pay as you go. As per your usage, you are going to be paid. Though inside the pricing, there are different parameters which we are going to discuss in coming slides. This was about Amazon CloudFront. Okay, so now you know what is edge location and regional edge caches, because with the help of these two components of AWS infrastructure, they are building the distributed system. Because with the help of edge location, they are caching the frequent data, and once that data becomes infrequent, infrequent, then that data will be automatically moved to the regional edge caches. We all know what is the difference between edge locations and regional edge caches, so I don't have to repeat this concept because we have already understood it better in the in our module number 2 or 3, I think. Okay, so these two components are used by CloudFront so that they can deliver the content without any latency to the global users. Okay, so now let's see what are the benefits of CloudFront. First of all, it is fast and global. Definitely, how it is global, because there are more than there are more than 180 plus these edge locations and regional edge caches are there total in combined. So that's why they are these are distributed among the globe. So that is why it is fast and global. I'm not going fast money. These all concept, okay? Look at this. These all things we have already discussed. Edge location, region, edge location, CloudFront, I've told you. So that's why whatever concept we have already discussed, that you already know, that we can do a bit fast, because we also have a guideline. I have to complete this course in 80 hours. Is anyone other is there who's also having the same issue that I'm going fast? Because it's CloudFront and these topics we've already covered, guys. Whatever will be the new thing, I'm going to take the time. Don't worry. You know this regional edge cache, everything. Money, so please, okay. I think you're not revising. Please revise. You're not doing the work from your end. If you're not going to revise and do the work from your end, then it will be difficult for you to pass the exam. Sorry. Okay. Please, okay. Please concentrate. I'm not going fast. The things you already know, that I'm not going to explain again, okay? If generally it is required, you don't know, then I'm going to explain again. Because I believe whatever I've explained you previously, that is understood. Okay. So now let's check out the benefits, guys. Okay, CloudFront benefits. So this is fast and global. We all know, since this is a global distributed, system, and with the help of that, the application performance is becoming very, very fast. And with the help of this global network, this particular CloudFront is, with the help of these edge locations and your regional edge caches, the availability of your static content will become global. Okay, security at the edge. These edge locations, these TLS SSL certificates are already installed on the server, on these edge servers. So your data transmission will be secured in transit. The data which we are, which is getting, transmitted between your origin server and edge location, and between your edge location to end user, everything is encrypted. That's why security is present at edge location. Third one, highly programmable. So at edge location you can also do some programming with the help of Lambda. So there is one Lambda at the rate edge. Lambda at the rate edge is one component of AWS. With the help of that, you can you can also do some programming at edge location. Suppose, for example, there is a scenario that whatever data is getting, whatever request you are getting from which are coming at edge location. Suppose we want to make a count, okay, and you want to store that count inside the DynamoDB table. So then you can write some program at the edge location, and you can each request will be countable, and that will be stored inside the DynamoDB table. That's why you can do multiple automation using Lambda at the rate edge. Okay, and then it is deeply integrated with AWS. Definitely, it is on the AWS platform. So multiple, you can integrate this with multiple, services you can integrate with. It works really well with S3. So suppose if you are having, if you have, yesterday I told you, with the help of S3 buckets, you can also host a static website. Suppose if you are hosting a static website, then you can use that static content to be delivered to global, global users using CloudFront. You can attach a CloudFront along with the S3 bucket, and then your static content will be delivered to, it will be delivered to all the customers without any latency to the global customer. So it works really well with S3. Apart from that, you can also use it with other services like EC2 and all, but it works really well with S3. It is cost effective. It is really cost effective. Okay, so you not be paying very much higher amount, and with this service, okay, you will get a lot of benefits. Okay, so now let's check out what are the pricing factor now. Okay, so how you will be charged if you are using a Amazon CloudFront. So the data transfer out, first of all, will be the data outbound. Data transfer out means data outbound, the data which we are sending from edge location to origin server, the data which we are sending from edge location to your end user. That is a data outbound. So for that, you will be charged. We all know AWS is having the same kind of a, that policy for that data outbound policy for almost all the services. They charge for data outbound. So for edge location also, you will be charged. So whatever data we are going to send it to the customer, whenever customer is requesting some data, that data is going to be sent to the customer. That is your data transfer out. For that you will get charged. The second part, the HTTPS request, charge for number of HTTPS requests. As I told you, the certificates are installed on edge location, so you are going to get all the HTTPS requests, and for that you will be charged. So for each request there will be very less charges. Okay, so for that also you will be charged. What are these HTTPS requests, guys? These requests, HTTP requests, are those which are sent from the client machine. So suppose, like when I am searching google.com and I'm searching for some data, then that request will go to the, suppose that request is going to the edge location or the origin server. So that is one HTTPS request. Okay. Now invalidation request means when you want to delete the when you want to delete the object inside the cache. So what happens, guys? As I've told you, whatever data which is inside the cache is a stale data. Stale data means a bit old data. So what happens sometimes? You have hosted a static website and you're using a CloudFront, and now at the back end, on the origin server, you have made some static changes to your website, but your website content was cached inside the CloudFront. That was cached inside the CloudFront edge location. So suppose if I'm trying to access a website content, I'm going to get the old content because the old content is cached. Maybe suppose I have written a policy that the content inside the edge location will be cached for suppose 20 minutes. So till 20 minutes, I would be seeing the old content because my request is getting served from edge location only. So in that case, what we used to do, sometimes we have to, delete that data from our end. And when we are invalidating that object or data, or invalidation means deleting. When we are deleting that data in that cache, in that edge location, inside that cache memory, that time you will be charged. You will be charged because if the data is all automatically getting, deleted. Like suppose we have created a rule that data will be in the cache memory for 30 minutes. So if that data is automatically getting deleted after 30 minutes, then there are no charges. But when you are explicitly deleting the data, so for that you will be getting charged. So it is written, there is no additional charge for first 1000 path requests. So suppose for first 1000 requests per month, you are not going to be charged. But apart from that, once there will be 1001 requests, then the charge will be starting and it will be around $0.05005 per invalidation of the object. So 1000 requests are free, guys. There is a capping, okay? For 1000 requests, it is free. Apart from that, whatever additional you're going to, use this facility of invalidating the object, for that you will be charged $0.005 per request, okay? So HTTPS, it is a protocol, a hypertext transfer protocol, and it is, it is a way how you are sending the data to it is a protocol which helps us that how you are sending the data to your how you are sending the request from your client machine to your server machine. That is the meaning of HTTPS request. So when you are Ashwini, when you are trying to access anything on any application, you are making a HTTP or HTTPS request. HTTPS is a secure request. So that request you are making to some origin server, and then origin server is going to send you the response in the same format, HTTPS format. Okay, is it clear, Ashwini? Okay. Now, what is the next thing? Okay, how you are going to charge for CloudFront? The final is your dedicated IP customer SSL. Well, as I've told you, guys, these edge locations have certification installed. So, these certifications also cost. So they're going to take some cost from our account also. So there is a fixed charge of $600 per month, which you have to spend, which you have to give. There's a fixed charge, which you have to give it for this certificate, so that your data will be secure. And this is a mandatory charge. Okay, you can't avoid, because when you are using this facility, this will be including in your bill, and you will get around 600 dollars per month. You have to give it, so that that certificate, that your data will be secure, because they are using SSL certificates, so that they can secure your data on the edge locations. These are the four kind of pricing of CloudFront. The first one is your data transfer out. The second one is your HTTPS request. Third one is your invalidation request, and the fourth one is your dedicated IP custom SSL. Okay, I think I'm not going that fast, because this is a new concept. So don't worry, whatever things we have revised, that we are going to accelerate. Otherwise, the new concept, I will take time to explain everything in detail. Okay, guys. So this CloudFront pricing is done. In how many ways we get charged? Now you know. Now let's move ahead. So this brings us, how to make that HTTPS request. No money. Suppose currently you log into your Amazon.com, search for some product. Once you search for some product, you are that HTTP request has been created, and that is sent to the origin server. That's how the HTTP requests are made money. Okay, whatever you are searching and you are sending that request to the server, automatically it is. Yes. So what happens, money? At the development side, okay, they create multiple APIs which going to hit. Okay, and these are all protocols are there. So at the web server, we have this HTTPS protocol is there. Invalidation request, please repeat, sir. Okay, invalidation request means when you want to delete the object. Delete the object means, Asha, deleting the files which is present at the edge locations. So when those files are automatically getting deleted, then there is no charge. But invalidation object means that you are going to delete it for some purpose. When you are going to delete those objects or files in the cache, in the cache memory at edge location, then you will be charged. So first 1000 requests are free. Apart from that, per month, and then you will be charged $0.005 per request for deleting the object inside the cache memory. Okay, Asha, is it clear? Okay, so guys, now so let's revise this. Okay, what we have learned in this section. So CDN is a global distributed system of caching server that accelerates delivery of content. Yeah, that is the main purpose of CDN, which uses a distributed system of caching servers using the edge location and your regional edge caches. And what is the service? What is the name of the service for this CDN? It is CloudFront. It is a fast CDN service that securely delivers data, video, application, and APIs over a global infrastructure. So these are all static data are there which can be delivered securely to global users without any latency. And CloudFront offers many benefits. We have already seen the benefits. It is fast, global. It is also cost effective, and you also it also say it is easy to scale, and the application performance also increases rapidly. These are all different kind of advantages of using CloudFront. Okay, so let me wrap up this module. So what we have learned in this module? So now you know the basis of networking. What is network? How the request flows? What is request response? And then what is virtual networking in cloud using VPC? What is VPC? The different components of VPC. Then we have also labeled a network diagram, how to identify the different components of VPC. And today we would have designed a basic VPC architecture, which we are going to see now. Indicate the steps to build a VPC, how to build a VPC, that you will learn inside the lab. And I have also shown you one demo video. So we're going to experience that now. And then identify security groups. What are security groups? How to create your own VPC and add additional components to it to produce a customized network that we have learned inside the lab. And identify the fundamental of Route53 and CloudFront that we have also checked. Let me take one question, then we're going to move to that activity. So just answer me. Which AWS networking service enables a company to create a virtual network within AWS? A is config, B is Route53, C is your direct connect, D is your VPC. Nitin, so we have discussed one topic, okay, that is CloudFront. So we have discussed that in detail. Now you can refer the resources and you can ask me a question tomorrow. So we have discussed the section 5 of this module, that is CloudFront. Okay, that we have just now covered. Now we are going to check out the activity and the lab. Within, first of all, please join in time, okay? Class, I'll just tell you today, but please try to join the class in time. Okay, because CloudFront is a content delivery service. It is a content delivery network service, which the main function of CloudFront is to deliver the content to global users without any latency using edge location and regional edge caches. So I think this concept I've already told you, I think in module number 3 or 2. So the same stuff is there, okay? So the same thing is there. Now you can check out like how the pricing is done for this CloudFront, that you can check, and tomorrow you can ask me if you have any doubt on this, okay? Now let's check out the now let's check out the answer. So I got multiple answers and most of you are correct. So guys, the correct answer is D. It is telling AWS networking service, which is helps to create a virtual network. So look at this. Config is not a networking service. The correct answer is D. So most of you got it correct. Now why others are not correct? Config is not a part of networking service. Route53 is a DNS service. It is a part of network, but it is a domain name system service. That connect is used to connect your on-premises servers to your AWS VPC. But which service is used to create a virtual network? It is Amazon Virtual Private Cloud, VPC. Okay. The correct answer is Virtual Private Cloud. Now, JSON is a format, okay, where the data flow, like data is flow. So you have an XML format, okay, in which the request will follow, these HTTP requests and all. And JSON we are using here, like, for that purpose, when you are writing IAM policy, there we are using the JSON, like it is a structured language. Okay. Okay. Okay, guys. Let's start this now. Okay, so this is now done. Now let's go back to the activity first. So given you activity as a homework, so I'll just open, yeah. Okay, so look at this. So this is the solution which I've created, guys. You can take a pic of this if you want. Now let me explain you the whole solution. Okay, it was telling that you have a small business with a website which is hosted on EC2. You have a customer data which is hosted on database, the backend server, which you want to keep as private. And you want to design a VPC which will meet this requirement. This first one is your web server and database server must be in a separate subnet. Look at this. First of all, I've created one AWS region. Inside the AWS region, I've created one VPC. I've taken the VPC CIDR as 10.0.0.0 divided by 16. Okay, which will give you roughly around 65,535 IPs. 531 IPs, I think. And now it is telling that we have to, there is a web server which is running inside which is hosted on EC2 machine. So look at this. This is we have created a web server. It is hosted on EC2 machine and one security group is attached to it. And now we also have a database server which is running privately. So this is our database server, and one security group is attached to database server, and it is running inside the private subnet because we wanted a we want this database in a privately. We want to run it as a privately. So look at this. I keep this web server inside the public subnet, and the private subnet, inside the private subnet we have the database server. Now the first address of a network must be 10.0.0.0. Look at this. It is 10.0.0.0. That is the first address. Each subnet must have 256 total IPs. So I have created, based on that, I have masked, I have done the submasking. So each subnet, the public subnet is having divided by 24. That is 256 IPs. The same way the private subnet is also having the 256 IPs, and in this I can use 251 IPs each. I can use because 5 IPs are blocked by Amazon for the internal purpose. And now look at this, guys. Both are different. The subnets are not getting overlapped. 10.0.1.0 and 10.0.2.0. These are the these are the different CIDR block. Okay. So this is done. Now your customer must always be able to access your web server, and your database server must be able to access the internet to make patch updates. So look at this. For my I have attached one internet gateway to my public subnet only. So that's how the customer request will go to internet gateway. From internet gateway it will go to public route table. From there we have attached a NACL because NACL work as security level, and then that NACL is also connected to the public subnet. This is the whole flow of the request. So since internet gateway is attached to the public subnet, the customer request will go to the web server. And now they are telling that for database server, we should only want, if suppose there is a patching, then only the internet is required. So for that we have launched one NAT gateway inside the public subnet, and that NAT gateway is connected to private route table. Because with the help of NAT gateway only, we are going to patch our database, because we are going to get the internet from NAT gateway only. And here from private route table, we have connected one security component, that is NACL, and that NACL is connected to the private subnet. And now, if whenever user want to, this application owner want to patch the database, they can patch it easily without exposing the database to the internet user. And this was the last thing. Your architecture must be highly available and use at least one customer firewall. So look at this. I have, I have created, this whole, into the two different availability zones. My web server is in availability zone A, and my database server is in availability zone B. That is, it is a highly available solution, and I'm using two security firewalls. First one, the NACL, which is at subnet level, and other one is a security group, which is working as a instance level. And this brings us to the end to this completes the AWS VPC designing of VPC activity. So you can take the pick if you want, and if you have designed the VPC like this, then also it is good. If you have tried, then also it is very good. Okay, no problem. At least you would have designed something. Okay, so you can take the pick and you can match your answer, and you can understand also now. If you have made any mistake, you can understand with this particular design. Okay, guys. So this activity is now complete. Now let me open this lab. Okay, let me come down and let me open the lab. Where's the lab? Yeah, this is lab. Okay, by the time this lab get open, I'm going to introduce you to the section 6. Okay, the section 6 of the course. Let me start this lab. Okay, so it will take some time, guys. I hope you understood the designing of VPC, and I believe you would have also completed that. Chinna, you're asking actions inside the JSON. Actually, when we are writing this policy, inside the action, you're going to define, what exactly, which particular services that policy belongs to. So under the action, you can write EC2 star, EC2 service you can mention, or you can mention S3. Under action part, we mention the services which will be followed for this particular, for this particular IAM policy. Okay, Chinna. I think this was the pending question. Yeah. Chinna, is it clear? Oh yeah. Okay. Thank you. Okay guys, by the time this lab gets created, okay, let me introduce you to this, okay, to this new module where we are going to talk about the compute part. So let's check out what is this in this, like what are the different things we are going to learn inside this module. Then we are going to switch back to the lab once the status is ready, and after completing the lab, we are going to come back to this learning part. Okay. So these are topics which we are going to cover in this module, and that is your first of all compute services overview. What are the different? What is this compute service catalog? What are the different services we have inside the compute? Though we already know what all services we are covering inside the compute, we are going to check out again. Then Amazon EC2. EC2 we are going to learn in depth how to create the machine, how to do EC2 optimization or cost optimization. What are the different components which are used to create EC2 machine, and different steps I'm going to tell you in detail. Then we are going to check out some container-based services which are used for containerized-based, which is used to deploy container-based application known as containerized application. And then we are going to see what is Amazon Lambda, and finally what is Amazon like AWS Elastic Beanstalk. So lot of learning is there in this module. There are few activities which are the part of this module. So three activities will be there, guys. So EC2 versus managed service. I think this won't be there. Sorry, two activities will be there. First one will be your AWS Lambda hands-on, and finally AWS Elastic Beanstalk. So there will be two labs for Lambda as well as Elastic Beanstalk. So these will be the part of activity. So that also we are going to perform hands-on for that. Then one recorded demo will be there, how to create EC2 machine, and finally we have one lab for EC2. So there will be total three hands-on and one recorded demo we are going to cover here, and finally one knowledge check question to just check what is the like understanding of these topics with this knowledge check. Okay, so what you're going to complete, okay, once you will complete this module, what you're going to learn, first of all you're going to learn, okay, to what are different compute services are there in the cloud, what AWS offers you as a part of compute services. Then why to use EC2, okay, what is the functionality of EC2, and identify the functionality of EC2 console. So the console, with the help of that we are going to create the EC2 machine. So what is the functionality of that? Perform basic functions in EC2 to build a virtual computing environment. So to create a Amazon EC2 virtual machine. Identify EC2 cost optimization element, how you can bring down the cost of your servers, virtual servers, that we will learn. Then demonstrate when to use Elastic Beanstalk and when to use Lambda. So we're going to learn about Elastic Beanstalk and Lambda. And finally, how to run container-based application, a cluster of managed services. So what are the different container-based applications are there? We are going to check in detail. Okay. So before starting the section 1 of compute service overview, let me check whether our lab is ready. Okay, so lab is still in creation, guys. No problem. So let's start with section 1, which is your compute service overview. No, this is a basic. This is a basic. We are still on the basic only. Once this foundation is completed, then we will move to architecting, which is the advanced part. Okay. Oh, it is taking a time. Okay, no problem. Okay, so let's start with section 1, which is compute services overview. So these services you are already familiar, guys. So I've already told you about these services previously. So the highlighted one in this particular screen we are going to focus on. So Amazon offers many compute services, and in this module we are going to discuss about the highlighted services, which will be the part of your examination. So we have EC2, we are going to discuss in deep, and then Elastic Beanstalk, the Lambda, and then we have few container-based services like your Fargate, your Elastic Kubernetes service, your Elastic Container Restore Directory, and finally your Elastic Container Service. So these all kind of compute services we are going to learn in this particular module. Apart from that, we also have other services. We are a part of service catalog like EC2 auto scaling is there. You have the VMware Cloud on AWS, AWS Batch, Amazon Lifesail, AWS Service, Serverless Application Repository, and finally AWS Outpost. I've already told you about these services in our previous modules. What are the overview of these services? What is the main functionality of these services? But the highlighted one, which is the part of your course, we're going to discuss in details. Okay. So let's categorize compute services, guys. So the first one, Elastic EC2. What is the key concept of Elastic EC2? We all know it is an example of infra as a service, where you can create, using this service you can create the infra. Infra means you're creating a virtual service which is a part of your application infrastructure. It is instance based. Okay, we are creating instance using this service, and what we are going to create finally, these instances are virtual machines. These are virtual machines on which your application is going to run. The characteristic provision virtual machine that you can manage as you choose. Definitely, it is an infra as a service. So you are managing these virtual machines because you're going to configure these virtual machines from the base level. So when you're configuring anything, you have to manage that. And finally, the ease of use, a familiar concept to many IT professionals. If you're going to your on-premises, you have the servers, the on-premises servers. On the same way, on cloud computing, AWS cloud computing, it is named as virtual machine. So it is a familiar concept. Those who have already worked in, like, who are working in IT industry, okay, they know the concept of server. Okay, we have the Linux server, Windows server, and those who have not, who are still in college, they also know what is Linux server. And but if they don't know Linux server, then they know Windows machines, because we are using the Windows laptops. Okay, in that Windows OS is installed. So a laptop is a single machine. So it is a very familiar concept for IT professionals. Now let's move to another service, which is AWS Lambda. AWS Lambda is a serverless computing. We all know it is a serverless computing where servers are there, but all are managed by AWS. For us, what we have to think, this is a serverless computing because we don't have to think about the underlying infrastructure, the underlying layer, and we don't have to manage that infrastructure. That's why it is serverless computing. Function based, it is also known as function as a service. So you're going to create Lambda functions, and it is also low cost as compared to EC2 machine. The characteristic of AWS Lambda, write and deploy code that runs on a schedule or that can be triggered as an event. So there are two kind of a Lambda function, guys. One is your, like a schedule Lambda function. Second is your event triggered Lambda functions. So the schedule Lambda function is that when we are scheduling a particular Lambda. So for example, let me give you, like an example here only. So suppose, there are developers are there, and developers are, doing the software development, and they're pushing the code to the development server. Okay. And each day, what is the business hours of of these developers? It is from 10 a.m. to 8 p.m. These are the timings. So after 10 p.m., nobody push the code to the development environment, development server. And before 10 a.m. also nobody push. So night is free. So now what happens? Suppose there was a, there was a problem that, lot of, bill was coming, and they have to optimize the EC2 service. EC2 cost optimization they have to do because this development environment they have created on virtual server using EC2. So they thought, okay, let's do one thing. Let's write a Lambda function. Let's write a schedule Lambda function. So once after 8 p.m., once that 8 p.m. the clock is going to trigger, this Lambda function is going to stop the development server, so that we are not going to be charged for the whole night. And we are going to write one more Lambda function that before the developer will come to the office at 10 a.m. and start pushing the code to the development server, we are going to do one thing. We are going to start the machine at sharp 10 a.m. using the Lambda function. So this is known as schedule based Lambda function. Yeah, this is scripting only. We have to write the code here. Okay, so this is an example of schedule based Lambda function, how you can start and stop the EC2 machine. The second is your triggered based Lambda function. So for example, suppose we have an Instagram kind of application, guys. Okay, where user is, suppose Mani is trying to upload his image and writing some caption. Okay, like my new hairstyle. Okay, suppose he has a haircut and he is writing my new hairstyle. So that my new hairstyle is the it is the metadata of that particular image. So suppose we got a task that we have to save the metadata of that particular image to a DynamoDB table. So for example, suppose that particular web application, the Instagram application is running on the EC2 machine. And now from here, whenever any customer or Mani is going to to upload a photo, So that photo will also contain some metadata. Suppose like what is the format of that photo, the size of the photo, then like what is the caption of the photo. That is a metadata. So suppose we want to save that metadata to the DynamoDB table. So now from that EC2 machine, from that EC2, the request has came to the EC2 machine, and that EC2 machine we have attached with the S3 bucket to first of all to to store that image. Now that image data will be stored. The image metadata will be stored in the DynamoDB table. So what is going to happen whenever any image is going to whenever any image is going to upload on the S3 bucket, then automatically one lambda will be triggered. Because what is the event here? Whenever you are uploading any image on on your S3 bucket, that is the event. A new image is getting uploaded on the S3 bucket. That is one event. So based on that, one event, the lambda will be triggered. The event based lambda will be triggered and is going to save the metadata of that image. That's how you can use the event based lambda function. We use when possible. So lambda function are used mainly for the automation purpose. So I've given you two examples of automation. Based on that, you can also use another set of automation example that you can use anywhere for any purpose to automate your infra. Okay. Relatively ease of use, a relatively new concept, guys. This lambda function were introduced few years back only. So, but it is not difficult to learn. Okay, so it's a relatively new concept. That is your serverless computing is a new concept, and for many IT staff members, but it is not so difficult to learn. It is easy to learn. The whole the platform of lambda is user friendly. So we're going to check out that at the lab. Okay, the third part is now services. Your ECS, EKS, Fargate, and ECR. So these are all your container based computing services. So whenever you want to deploy a microservices kind of application or containerized application, you are going to use these set of services. Characteristic: spin up and run jobs more quickly. Definitely, these container services are faster as compared to the traditional services which we are running on, which we are running on these virtual machines. So that's why these services get started very quickly, and these also runs pretty fast as compared to services as compared to the applications which are deploying on EC2. The ease of use: AWS Fargate reduces the administrative overhead, but you can use options that give you more control. So there is AWS Fargate is a service which is created at Amazon only. So which is which is a fully managed service. That's why it reduces the overhead. Apart from that, if you want to do the configuration from here and where you have more control on the on your container based application configuration, so you can use the other things like ECS and EKS for that. This is the ease of use. So mainly these are used for deploying the container based application. Finally, we have Elastic Beanstalk, which is the example of platform as a service, and mainly it is used for web application deployment. So here the characteristics of using Elastic Beanstalk is that first of all, it is going to increase the developer's productivity. How? Because the focus is only on the code. Suppose Mani is a developer, he don't know anything about infra, so he can use Elastic Beanstalk to deploy his application. Because he is a developer, so he can focus on writing a good quality code. Can easily tie into other services like database, domain name system, etc. You can also integrate this Elastic Beanstalk with your like O53, which is a domain name service, and you can also use database also inside this Elastic Beanstalk. That is also the advantage. Ease of use: fast and easy to get started. It is very easy. You have to just create one Elastic Beanstalk environment, then the deployment will be done automatically. It is very fast and easy to use. These are the categorizing of compute services, guys. Okay. Container. Okay, container. Nathan, I think I've already explained you all the stuff. Serverless. Nathan, serverless means when you are not creating any infrastructure. Your application is running on without servers. Your application is running without servers. That is serverless. So Lambda is a serverless computing where you are not creating any servers. Suppose you are running any Lambda function, you are not first of all creating any machine like EC2, then you are deploying your application service. No, It is a serverless computing where there are no server. You don't have to worry about creating the server. You don't have to worry about managing the server. That is the meaning of serverless. Second, container based means, you know, like container based, container based means containers, like there's a concept of microservices deployment. So there we use these containers. So container is just like it is a, what do you say, like it is a container, you can say, a box. Inside that you're going to, put all the, application code, the binary, the dependency, and it will be tightly inside a container. So inside a small container you're going to run all the applications. Like we are going to run all that particular microservice. Don't worry, this container and how to create the container, which particular platform is required to create the container, we're going to learn in in the coming slides. Okay, so don't worry about that. Okay, definitely. EC2 and Elastic Beanstalk both are EC2 is an example of infra as a service, Chinna, where you have to create the virtual machines. Elastic Beanstalk is the example of platform as a service where you don't have to worry about managing the infra, creation of managing the infra. You only have to just bring your code and deploy it on the server. Okay. Yes, it is possible. It is possible to run the application without server. It is 100% possible. You can create your entire application using AWS Lambda function, and you can, that is the meaning of serverless computing money. Okay, so this is also ready, guys. Let's do one thing. Let's take break now, okay? Because this lab otherwise will get the time will up. Okay, let's take one break, okay, for 5 minutes, and I'm going to see you after 5 minutes, and we're going to first discuss about this lab. Then we're going to move to the further topics. Okay, let's catch after 5 minutes. Okay. Hello everyone, welcome back. So now let's start. Let's start with the lab. Okay. So our lab is ready now. Let's start with the lab. Let me just close this. Click on AWS. It's going to open a lab for us. Okay, let me move this to another tab so it will be easy for me to copy paste. Okay. So now here we have to build the VPC, the custom VPC, the VPC which we are going to build, and inside that we are going to launch a web server. So how we are going to validate the once we will check out the response from the web server, and once we will get the response, that means our whole network setup is like it is set up correctly. Okay, so let's go down to the task. So this is what we are going to see as a as a final infra. I have already explained you yesterday. Okay, so this is we are going to create, guys. So the first task is to create your VPC. So if you remember yesterday, okay, this particular AWS, they are also modifying their console. So whatever video I've shown you that yesterday, the demo of VPC, that video was having that old old console. Okay, so that's where we are using the wizard and all, the VPC wizard. So this is a new console this console will be replaced by the old console. So let's check out using the new console. So you have to first select VPC. So you can find it under the network. So you can come down and check out the network and content delivery, and you're going to find the VPC service. So click on VPC. Okay. So here you have to click on create VPC. This is a new console. So whatever I'm going to create, it is going to show it under the preview design as well. So the VPC setting, we're going to do VPC and more, because we also have to create the subnets. So here we have to provide the name of the VPC. So here inside here, okay, whatever steps I'm showing, everything is documented. Okay, you can also read one by one step, and you can also check. Okay, but concentrate in the lab now. So here they're telling we have to provide the name of the lab, name of the VPC as lab. Let me copy this and just replace it with the project. Now look at this. It is automatically changing in the design. Now the CIDR block, let's keep it same. I think they've given the same. The IPv4 CIDR block will be 10.0.0.0 divided by 16. 16 is your masking. So it is same, and we are getting around 65,536 IPs inside our VPC. We are not using IPv6 CIDR block, and tenancy will be default. That is your shared tenancy. I have already explained you. Number of availability zones. So as per the lab, we have to keep number of availability zone as 1, and number of public subnet as 1, and number of private subnet as 1. So number of availability zone we are keeping at 1. We'll come down and look at this. It is going to take the US East 1, the first availability zone. Okay, and that is only required for the lab also. Number of subnet 1, and number of private subnet, public subnet 1, and number of private subnet also 1. Look at this. These will be the two subnet. One will be your public subnet, other one will be your private subnet. Now we'll come down. Now let's customize the subnet CIDR block. So what will be the CIDR block of public subnet and private subnet? So for public subnet, the CIDR block will be 10.0.0.0 divided by 24. Let's divide it by 24. Same IP, we are getting roughly 256 IPs. And for private subnet 1, we have 10.0.1.0 divided by 24. Let me just change this private one, guys. Okay. Yes, 10.0.1.0 divided by 24. So this is our private subnet CIDR block. Next, we have to set a net gateway in 1AZ. So net gateway, suppose if you are running your application in multiple availability zone, so you are having two choices. Either you can put a net gateway inside a single availability zone, or you can create net gateway per availability zone in each availability zone. So we're going to see, we are going to put one in one availability zone. So this will be inside this US East 1A public subnet. Okay. Now VPC endpoint is not required, so none. It is not required, guys. Okay. 10, 192, 192, 198, 172. These are all like the range of the private IPs. It is not like it can start from 172 also. Nathan. Okay. So now guys, we'll come down and here, okay, NAT gateway in one zone. There is no VPC endpoint. We're not attaching any VPC endpoint. We will enable the DNS host name and resolution. So I think the configuration is now completed. Yes, it is that the same configuration written here. And now look at this. Under the preview, you will see the lab VPCs are lab VPC. These are the two subnets, and they are going to create one route table also automatically here. So the public subnet will be automatically assigned associated with the public route table, and the private subnet will be automatically associated to the private route table. Okay. 10 range means that is IP range 10 dot. You can put 172.0 also. That is not fixed. Any IP range you can take. Okay, you all know how to calculate the IPv4 range. Within you can take any IP range. It's not like that. It is fixed that the private IP is going to start from 10.0. It is not like that. Yeah, like for this experiment they have taken, but that is not only like that is mandatory. You can also start from another IP range also 172. Okay. Okay guys, so this is the preview of this particular VPC. So let me click on create VPC. So now it is creating all the components. So currently it has created one VPC and enabled the DNS hostname and resolution over here. So at the VPC level, all the components or like all the machines, all the EC2 machines which we are going to launch inside this VPC will have a DNS hostname also attached to the each machine. Then we have a VPC creation. This is a VPC ID. Our subnet is created. Two subnets are created. It has also created one internet gateway, and then it has attached the internet gateway to the VPC. Then it has created one route table, this route table, and then it has created the routes, the local routes, and one route for public subnet for internet gateway, and another route for NAT gateway towards the private subnet. And then it has also allocated elastic IP. So we all know why elastic IP is required here, because NAT gateway needs one elastic IP. I've told you. So now that elastic IP will be added to the NAT gateway, and then NAT gateway will be created. Now this NAT gateway takes some time to activate. Maybe it will be taking few minutes. After that, once this NAT gateway is activated, then it is going to create another route table, maybe for the private route table, another private route. Then it is going to create the private routes. It is going to add a route for NAT gateway, and then it is going to associate this route table to private subnet, and finally is going to automatically validate the route table creation. So with the help of this new console, it is becoming more easy to create the VPC. Otherwise, these all steps we have to do it manually. We have to create one internet gateway, then we have to attach that to VPC. Okay, that was the part of the old console. Now with the help of new console, with the help of single page, we are going to create so many resources. So it is saving a lot of time. Okay, and we all know then too, I've already explained you which components are connected to which part. So if you want to if you want to if you got a chance to work on that old console, you can also do in the same way. The process is same. Okay, so it will take. Let's see what are the next steps, because it is going to take some time. So once it is done, we have already seen the preview where we have seen what is the name of the VPC, the subnet, the route table. I've already showed you in the preview, and then we have created the VPC. So it is now creating all the components of VPC which we have defined. After this, what we have to do, once this VPC is created, now this VPC is created, look at this, everything is now ticked on green. Now you can click on View VPC. Now look at this, this is your VPC, this is your VPC ID, and now look at this is your subnet. So you can do one thing, you can filter out with the help of VPC ID. So this is our lab VPC which we have created. This is the VPC ID ending with 583. So under the subnet, lot of subnets are there of different VPCs, because there are 3 VPCs are there which are created here. If you think, look at this. This is one default VPC. I have told you each and every region will have a default VPC. If you are not creating any VPC, then all the EC2 machines will be all the EC2 or database servers will be launched inside the default VPC. This VPC we have created, and this VPC was already the part of this lab, okay, which was created by the lab. Okay. So now we have, this is the lab VPC, this is the VPC ID 583. So these are the different subnets of all these VPCs. So let's filter out the subnets 583. So till now we have created two subnets, guys, one public and one private subnet. Under route table, so let's filter out with the VPC again, VPC ID. So these are the route tables which belongs to, like, which belongs to this VPC. So look at this. These were the two route tables which were created, the public and one private route table. And these are not main. There is one main route table. So whenever you will create a route table, there will be one main route table. And whatever route table you're going to create, whatever route table you're going to create additionally, that won't be the main route table. Okay. Now under the internet gateway, guys, it has created one internet gateway, lab IGW, and it is attached to our lab VPC. Okay. And then we have also created the NAT gateway. Under NAT gateway, look at this is the NAT gateway now. And this is the elastic IP which is attached to this NAT gateway. Okay. So I have shown you what all things are created. So till now we have created this part of our infra, and where we have, this is the lab VPC CIDR block. Inside that we have created, inside the availability zone A, that is US East 1A. We have created this one public and one private subnet, and there is one internet gateway created, and inside public subnet 1 we have also created one NAT gateway. Now let's add more configuration to this particular VPC infra. So now the next task is that we have to create the additional subnets, because look at this. To complete this whole infra, we also need two more subnets. So let's create two more additional subnets now. Okay. Let me go here. And let me just copy the subnet name, okay? Okay, so to create the subnet, you have to come here, click on subnet now, and click on create subnet. Under which VPC we have to create? We have to create inside the lab VPC. Automatically it has shown you the CIDR block of the VPC. Now let me provide the subnet name. I've copied it from there and pasted over here. Now availability zone. Now this infra we have to create inside another availability zone. Let's select US East 1B. The same is mentioned here, US East 1B. IPv4 CIDR block is 10.0.2.0 divided by 24. Let me put it like that. 10.0.2.0 divided by 24. Yeah, the same one. Okay. That means whatever machine I'm going to, launch inside the subnet will start from 10.0.0 D0.2. Okay. Now it will come down, and let's keep everything as optional and click on create subnet. So in the same way, look at this subnet has been created, lab subnet public 2. In the same way, let's create one more private subnet inside another availability zone. So select the same VPC, lab VPC. Let me copy the name of the subnet here. Yeah, lab VPC private 2 is the name of the subnet. Let me paste it over here. Now availability zone, it will be US East 1B, another availability zone. Okay, the same US East 1B. IPv4, this is now another CIDR block 10.0.3.0 divided by 24. Let's say 10.0.3.0 divided by 24. Okay, so this is another. If suppose I was telling you, if suppose I will give the previous CIDR block, the same CIDR block of another subnet, it is going to provide the error. Look at this. If I'm giving this wrong subnet, this CIDR block of previous subnet, then look at this. I'm going to create, it is going to give me the error, guys. Look at this. CIDR address overlap with the existing subnet. That's why we have to give unique CIDR block. Let me just change it to 3. Okay. Yeah. So this was the correct one. Let's come down and click on create subnet. Now there won't be any error. So now our two public and two private subnets are created. Let's check it out. Let's filter this, guys, using VPC filter. Yeah, this was the okay. So now look at this. These are four. Like there are two public subnets and two private subnets. And look at this. These are having different CIDR block. All are different CIDR block. And you can also see here, it is here for different availability zone. Like two are in US East 1A, one public and one private, and another two are in US East 1B. Now just can you just quickly just tell me why for all like different like three subnets we are having 251 IPs, and for this public one subnet, for this public one US East 1 subnet we have only 250 IPs. Can anyone tell me? Just try. Why? Why we have one less IP here? Any idea? No, this is not a default VPC, Shrikant. Come on. This is not a default VPC. We are making custom VPC. Who told this? This subnet was a very good, Durga, very good answer. Because of NAT gateway. If you remember, we have, we have launched NAT gateway inside public subnet 1. So it is going to take one IP. That was the elastic IP. That's why it is 250. Okay, very good, Durga. Okay, so now this is done. Let's move and check what is the next step. Okay, now we have to modify the route table. We have to add these additional subnets to the route table. So let's go to the route table. So first I'm going to show you the route table configuration. Let me first filter out the route tables which belongs to this VPC, lab VPC. Okay, so let's check out first private route table, guys. This is a private route table, and under the routes we are going to see two routes. One will be your local route and other will be your NAT gateway route. Okay, and now let's check out the subnet association. So till now, one private subnet is attached. So we are going to add another private subnet over here. Click on edit subnet association and select another private subnet 2. Click on save association. So now when you are going to validate it, just select this route table, and under subnet association you are going to see two subnets associated with this route table. In the same way, let's add the public subnet to that public route table. So select this public route table. So first let me show you the routes of this particular route table. Under routes you are going to see there will be one local route, other will be your IGW, internet gateway route. Okay, let's come upside and click on subnet association, and currently there is only single subnet associated, that is your public one. Let's edit the subnet association and add your second subnet, your second public subnet. Click on save association. Okay, so now look at this, both route table is having two subnets each, guys. Okay, so now what we have to do, so now we have completed this part also. Now let's see what is left. Yeah, okay, so till now look at this, these are the same routes I have showed you on the console, and now this infra is completed. Now we have to create one security group, because security group we are going to attach the security group to our EC2 machine, to our web server. So let's create the security group. Let me just copy the name of the security group. So to create the security group, you have to just navigate down, and under the security, click on security group. Okay, so let's click on create security group. Provide the name of the security group. Let me paste it here. Under description, what is the description? Enable HTTP access. Let's copy this. Okay, so let me cross this VPC, because it is taking the ID of default VPC. We have to associate the security group with our lab VPC, which we have just now created. This is our lab VPC. Look at this. This is our lab VPC. Okay. We'll come now. Now we all know that this security groups are stateful. So we only have to provide the inbound rule, because at outbound it is automatically allowing all the traffic. So click on add inbound rule, and here we are going to open port number 80 for HTTPS traffic. Look at this, port number 80 we are going to open, guys. So under type we are going to check for HTTP. It runs the port number 80, and source will be anywhere from anywhere IPv4 address, like any IPv4 address, like internet IP. It is okay. So the same way, now let me copy this description and put this. This is optional. Okay. This is your learning. Okay, now this will be learning for you for your let's compute lab. Compute lab, we're going to create one EC2 machine. So same kind of a step will be there, guys. Okay. So now this is done. Keep everything as default. We have completed everything. Now click on create security group. Now our security group has been created successfully, and this is our security group ID. Okay, the next task is now to launch a web server instance. So to launch a web server instance, we have to navigate to EC2 service. Search for EC2, or if you want to check under the services, click on services. Under compute, you will find EC2. So let's launch one EC2 machine. You can see currently, if you want to see all the running instances, you can see it from here. Currently, one Bastion host is currently running. We are not going to use the Bastion host inside our lab. It is running. Okay, so let's click on launch instance. Let's provide the name of our instance. Let me copy the name of the instance. It is web server 1. Okay. These all things, what are the configuration here? We are going to learn in the compute section. Okay, so don't ask me question here, because each and every configuration will tell you what is this AMI. Okay, what are the different configurations are there? We are going to learn inside the compute. Okay. So now we have to select the AMI. So let's select this Linux AMI, and we are going to select this basic one, Linux 2 AMI. Okay. Keep this as a default. Now next, we have to set the instance type. So we are going to select the basic, that T2 or micro instance, which is a free tier eligible instance, which is having 1 VPC and 1 GB of memory. Under key pair, we have to set the Walkie key pair. The same steps we are going here also. These are the same steps. You can read out the steps and you can do it off. Okay, the same stuff is there, guys. So Walkie is a key pair. What is key pair? We are going to learn inside this complete part. Okay, what are the components of key pairs and all. And then we are going to come down. We are going to come to the networking setting. Now this is the networking setting. So here you have to edit the networking setting, because currently it is using the default VPC. But since we have created our own VPC, we are going to launch this instance inside our own VPC, that is our lab VPC. And then we have to set the subnet. Let's see which subnet they are aiming for. So we have to launch this instance inside the public 2 subnet. So select the subnet. Look at this. The 4 subnets are there, which we have created as a part of this VPC. We are going to select this lab subnet public 2, the same one. Look at here. Okay. We also enable the auto assign public IP. So we are not using elastic IP here. So we are going to, once the server is launched, it will automatically get IP automatically assigned, the public IP. Now let's select the firewall. So we have already created one firewall, the security group. We are going to select that. So click on select existing security group, and here select the web security group which we have created just now, where we are opening port number 80 for HTTPS traffic. Now let's come down, and under the config storage, keep this as default. This is your disk, okay, which will be attached to your EC2 machine, where your OS is going to, operating system is going to install. Let's keep it at default 8 GB of this type, general purpose SSD. What are these different kind of storages? We are going to learn inside the storage section. Okay, now let's go to the advanced details and directly go to the end of this particular detail, and there is a user data. Inside user data, we are going to copy this script. We are going to copy this script. We have completed all these steps till now here, and there is a script we are going to copy and put it over there. So this is a bootstrap script. Let me tell you a little bit about this bootstrap script. These are the bootstrap scripts which runs at the time, once the EC2 instance is going to boot for the first time. That time this script is going to run, and it is going to install whatever software we are putting inside this particular script. So this is a shebang operator, guys. This first line has exclamatory mark bin bash is a shebang operator. So inside this only all these operations is going to perform. So it is defining from here, it is telling the system server that go to this shebang operator directory, and from here you have to perform all these tasks. So what we are doing, we are going to install Apache web server and a PHP application. So these are the commands. This is the first command of Linux command, yum install -y httpd mysql php. So it is going to install yum install -y means whatever yes or no will come in between. It is automatically going to take yes -y, and this is the HTTP. This is your Apache service. This is your MySQL service, and this is your PHP service. After that, it is going to take the code from this particular S3 bucket using wget command. Wget command is used to get the code from the from the internet. So it is going to take this file which is located inside this S3 bucket, and then it is going to unzip this file to this location. It is going to unzip this file to this location. This is the location of the directory of Apache var www html. Inside that we are going to place that PHP code file, and finally it is going to start the Apache service. So first of all, check config httpd on. So this is the service. Okay, this is one command I'm going to tell you after this command. So then we're going to use this command service httpd service. So this service just a minute. Yeah, sorry. The service httpd start is going to start this Apache server. Okay, and then this check config http on, what is going to do? It is going to enable this service in such a way that if your machines get restarted also, then also this service will be enabled. Okay, it will be starting automatically. It won't be down. It is going to be there. The service will be up and running. That's why we use this check config httpd on. These are all Linux concepts. Okay, so now this is done. I think all the configuration is now completed. I have explained you each and every step of this script also. This is a bash script. So now let's click on launch instance. Now it is going to launch an instance. So now click on view all instances. So let me just refresh this now. Now look at this. Currently the state of the instance is in pending. So by the time it will move to running status, let me also show you few of the network components here. So under networking, guys, you can see the VPC ID. This instance is launched at the lab VPC. And then you can also see the subnet ID. So what subnet we have chosen? The public 2. So it is launched at the public 2 subnet. Apart from that, under the security, you can see web security group which we have created at VPC level has been attached to this particular instance, because we have chosen all these things as a part of the EC2 configuration. And look at this. This is your instance ID B62. So currently the state of the instance is now running. So now it is going to, at the time of booting, it is going to, it has already run all those scripts. Okay, the user data script. Let's validate now. So this particular server should give us the application, the PHP application which we have installed on this web server. So to access the application, either you can copy this DNS or you can simply copy this public IP. Open a new tab, paste this public IP, click on enter. Enter is not working or what? Okay. So it is loading the website. It takes time, okay, it takes a few minutes to load all the user scripts. Look at this. Our application is now up, and this was the application, PHP application which was created. And look at this. It is giving us the two values, the instance ID and the availability zone of a particular instance. Look at it, it is the same instance ID 62 and it is launched inside US East 1B. The same response we are getting here. So this was how you can create VPC and you can launch your web server, and we have validated our application is running fine. That means inside this VPC, all the configuration is done correctly and our customers can be easily able to reach out to our application using this IP. That means all the components are working as expected. I think this brings to the end to this lab. Please complete the lab. This is very valuable. You will learn a lot. So we have completed this whole infra, guys, and we have also validated the functionality of the web server. Okay, so let me close these tabs now, not required, and let me just end this lab. So all the labs till now are complete. Activity is complete. Nothing is pending. Please perform this lab and try to perform the lab on time. It will help you a lot. Okay, so you have to just close this and go back to the modules. Okay, so we have completed the lab also. Now let's move back to the concepts of our compute module. So now the next concept is your choosing the optimal compute service. So since I told you there are multiple compute services, guys. So when there are multiple compute services are there, those are used for different kind of a purpose. Okay. So that way they are telling that for for your application, you should always choose the optimal compute service which is required for your application. So the optimal compute service of services that you use will depend on your use case. Definitely. Suppose I want to deploy a container-based application. For that, I know there are few compute services on AWS known as Elastic Compute, like Elastic Container Service, Elastic Kubernetes Service that I'm going to use. Suppose if I want to deploy my application on a virtual server, I'm going to use EC2. Okay, so based on your user case, how is your application designed? Like some aspects are there. What is your application design? Whether it is a it is a microservices based application, containerized based application, or is a multi-tier application. Based on that, you are going to choose the compute service. What are your usage pattern? Are you depending whether you are going to use this service for longer period of time, like for use this use these machines for longer period of time or for shorter period of time, and then which configuration settings will you want to manage? Suppose if you want to install a database if you want to create a database server, that is a different configuration. If you want to create a web server, that is a different configuration. So with all this aspect, we have to decide which particular compute service is optimum for our use case. Selecting the wrong compute solution for an architecture will lead to lower performance efficiency. Definitely. Suppose I want to deploy a container-based application. So what I'm doing, I'm deploying it on EC2 instance. Like I am managing from myself. I'm installing the Docker, I'm installing Kubernetes, creating all the cluster and all different kind of stuff. Lot of time wasting. When we already have ECS, EKS, Farragut kind of services are already on the console on like AWS platform, then why you are going for EC2? So that's why they're telling always choose a correct compute solution. Apart from that, the configuration of a particular machine. Suppose we are using a EC2 machine, and if suppose we are using a low compute machine like T2.micro, 1 VPCU, 1 GB of RAM, and our application requires more power, more compute, more CPU power, then also we are selecting a wrong compute solution. In that case, we have to select a higher instance type. Because if you are selecting a wrong compute solution, it will degrade the performance of your application. So a good starting point is to understand all the compute options. Whatever compute options are available on AWS, you should understand them all, and then you should decide that which compute solution you have to go for a particular use case. Okay. So now let's start with the section 2 of this module, that is your Amazon EC2, that is Elastic Cloud Compute. So this Elastic Compute Cloud or Elastic Compute Cloud is a resizable cloud. When I tell resizable, you can stretch and you can compress the configuration of a virtual machine. And what is the functionality of this EC2 service? It is used to create virtual servers. It is used to create virtual server. That is the functionality of EC2 service. So let's discuss this in detail. So EC2 is also known as Elastic Compute Cloud, and using this service, you're going to create you're going to create virtual machines. On that, you can run your application servers. Like multiple purposes are there to use this virtual machine. You can use the application servers. You can use it as a web server, a database server, a game server, a mail server, a media server, a catalog server, a file server, a computing server, and a proxy server. So for multiple purposes, you can use this EC2 machine. Now it is also giving you like diagram, difference how these looks for on premises and your on your this Amazon EC2. So look at this on premises. This is the hardware part of compute. Inside the rack, this this compute machines, these servers are put in different racks, and everything is connected with multiple wires and all. So this is how. And same way, this is a architecture of this is a diagram or this is a diagram to represent your EC2. This is your diagram, guys. These are all separate EC2 machine. So here we are using this hardware as a software in the form of EC2 service on cloud computing platform. Okay, so this service, with the help of this service, we are going to create a virtual server, and which is used for multiple purposes. And the examples are there, which I've already told you. These are used for vast purposes, and these are different examples. You can create game server, mail server, media server, application server, anything you can create using these virtual machines. Okay, so now let's move ahead. Now let me give you what is EC2. What is EC2? So EC2 is a elastic compute cloud which provides virtual machines, which is used to create virtual machines, and these machines are known as EC2 instances. The machines which are created using EC2 service is known as EC2 instances. You can also you can also refer them as EC2 machines or EC2 servers, but ideally in AWS we refer these virtual machines as EC2 instances. Okay. EC2 service gives you full control over the guest operating system, so whether it is Linux, Windows, or Mac OS. That's why it comes under infra as a service. So you can create different virtual instance. Instance means a server. Same thing, Hital. Instance means server. Just you are referring. Instance you can consider as a abbreviation. Okay, like or you can say it is a synonym. Sorry, it is a synonym of server. The same thing. Instance and server is the same thing. Okay, Hital. Okay. Okay, guys. So here it is a EC2 is an example of infra as a service. That's why whenever you're going to create a machine, just like go 10 minutes back and where we have created one EC2 machine, guys. You have seen we have done whole configuration from our end. I have I've given the name to that machine. I have provided what kind of instance type it will have, what kind of EMI it is going to have, which key set is going to choose, which security group will be attached. So everything when I'm doing from my end, that means I'm having a full control over this EC2 machine. Okay. You can launch instances of any size into any availability zone anywhere in the world. There is no restriction. You can choose any type of instances, like we have choose T2.micro, which was a free tier eligible. So like that, you can also choose, like advanced or higher configuration, like higher instance type based on your like application requirement, and you can launch these EC2 machines in any availability zone inside any region, like inside any region of AWS infra. Okay. Launch instances from AMI. So one prerequisite is this AMIs are required to launch EC2. So if you remember, when I was creating that EC2 machine, I have to, the first step was that I have to, like after giving the name, that was not a step. The second step was, the main step was to select the image, Amazon machine image. So this Amazon machine image or AMI is a image of your operating system. So they have created one image. Let me give you an example, okay? And then I think you can connect them better. I think most of you guys would have installed these Windows from your side, like you're working, either you're working or you're in college. Any point of time, your laptop would have got crashed, and you would have installed your OS. How you would have installed? You have installed it through that image, ISO file. Okay, you have to burn it in your pen drive, or you have to burn it on your CD, and then you can install your Windows 7. So you can consider that image of a Windows or another Linux or Mac OS system as an AMI. So with the help of Amazon machine image, you can create EC2 machines, guys. We're going to discuss about AMI, different kind of AMI, how to create the AMI in the coming section of the course. But till now, you should understand what is AMI, okay, and what exactly is the purpose of AMI. Launch instances with a few clicks or a line of code, and they are ready to make. As I told you, how many ways we can access AWS services through management console, through your CLI, through your SDK. So either one thing I've told you, one form of creating these machines I've told you just now as a part of Lab 2 using the console. Apart from that, you can also create this EC2 machine by writing a simple line of codes using your SDKs, which are done by developer, also using Amazon CLI. So we can write the code, and with the help of that we can create the machine. So EC2 machines can be created from console as well as using the code through CLI and SDKs. You can control traffic to and from instances. How we are controlling the traffic? Using security groups, because security groups works at instance level. We are directly attaching the security group at EC2. If you remember, I have attached a security group with EC2 in our Lab 2. So with the help of that security group, we are controlling the traffic at from which port the traffic is going to enter your web server. Okay, so this is the EC2 overview. Okay, guys. So now we are going to see how you can launch an Amazon EC2 instance. So, guys, the process which I showed you as a part of Lab 2 was was the process which we were performing using the new AWS console. They have modified their outlook, but here the steps which are given, these are for traditional console. Okay, so that everything is same. Just understand this, and whenever I'm going to do this lab, okay, I'm going to do it from old console, so you will get the same idea. Okay, but the steps which will be there in the lab will be for new console, so you can perform from new console, and you can also learn from old console, which I'm going to do inside the lab. Okay, so launching an EC2 instance, this section of the module walks you through all the 9 key decisions to make when you create EC2 instance. What are these decisions? Like adding a security group, okay, adding a key pair, selecting the instance type, selecting the AMI. These are all which are the part of key decisions, which are the part of the configuration of EC2 machine. So we are going to see how we can do this configuration using our AWS Management Console launch instance wizard. Along the way, essential EC2 concept we are going to explore definitely. With each step, I'm going to explain you why this configuration is required, what is the meaning of this configuration, okay, what is the functionality of this configuration. So let's start with the AMI. So the first step, the foremost step I've told you, you have to select an AMI. So I've told you AMI is your Amazon machine image, which is a template that is used to create an EC2 instance. I've told you with the help of AMI, you're going to create the EC2 machine. So this AMI contains a image of your Windows, Linux or Mac OS operating system. Often also have some software pre-installed. So if you will see on the console, if I will show you the console, there are n number of AMIs are there. Many AMIs are there. So few will be very base AMIs where softwares are not installed. But there will be few AMIs where you will get pre-installed software. Suppose you want your Linux machine like you are creating a database server. So one AMI you will get like base AMI where nothing is installed. No software installed, only OS is there. A image of OS. Then you will find few more AMI. There you will find that along with the OS, you also get MySQL already installed. So you don't have to install it from your end. You can use that AMI as well. So that's why they're telling there will be some AMIs also where you will get some software pre-installed, like SQL Server, some containers, ECS already installed, or some other kind of a software like already installed. Will be like PHP is already installed, like that. AMI choices. So from these 4 things you're going to choose the AMI, guys. First one will be your quick start. So under the quick start, so the AMI which I've chosen in our last lab, I've chosen under the quick start. So quick start is going to provide you all the Linux, Windows and Mac OS AMIs which are created by AWS. So AWS is going to, AWS has already created AMI for you, which will be the part of quick start. Under my AMIs, so there is the option to create AMI from your end also. So those AMIs will be under the My AMI tab. Okay, and the third one is your AMI marketplace pre-configured template for third party. So AWS has, AWS has also hired some third party vendors, and they can also create some, some AMIs. Suppose some pre-configured AMIs which are already having some kind of configuration. There's a LAMP stack is there, which is used to create a simple, web, some simple you can install a PHP application. So it is going to give you a Linux, Apache, Linux, Apache, MySQL, and PHP. A stack will be there. So these are the kind of a stack which will be created as a part of our AMI, and that AMI you can get it from AWS Marketplace. These are customized AMI. Okay, there you don't have to install these softwares. You don't have to make the connection. It will already you can directly install, you can directly deploy an application on these servers, a PHP kind of application using Linux, Apache server, and MySQL. Okay. Then we have community AMIs. So, we have AWS community builders. So community builders are those who contribute to AWS. Like, once you will get certified, you can also work as a AWS community builder. Then then you can, like, you can create some AMIs, and you can, like you can send it to AWS, and they can put it under the AWS platform. So these are community AMIs. The people who are the community builders, like us, the people like us who are certified AWS architects, or some other certified, like some other AWS certified people. So they build their AMI and they put it under this community AMI. So these AMIs are risky to use because you don't know whether anybody is providing some AMI which contains some virus. So we don't recommend to use this community AMIs until unless it is very, very necessary, because these are not verified AMIs from third parties. You can take the AMIs from marketplace. You can purchase the AMIs from marketplace, because these are created by the third party vendors. But community AMIs is an open platform of AWS where anyone, like I, can also push one AMI. So these are not getting validated. So that's why, like community AMIs are, if you want to use it at your own risk, because it can harm your system as well. Okay. So these are the different kind of AMIs, the category from where you can choose the AMI. And now we understood what is AMI. As the diagram says, AMI is helpful for launching the EC2 machine. So this was about AMI. Okay. Now let's move to how you can create a new AMI. With this example, you will understand how to create a AMI. So I told you few AMIs are already there. Okay. Like already there under this quick start, marketplace and community. And whatever AMI you're going to create, that will be the part of my AMI. So how you can create the AMI? So first thing is there. Okay. Under the quick start, or like you can select one base AMI. Suppose we have selected one Linux Amazon 2. Amazon Linux 2 is one very base AMI where nothing is installed. Now, that AMI you have taken, and as a part of launching the instance, you have, like currently this AMI is not modified because this is a base AMI, the first step. Now using this AMI, you are also doing the configuration. So if you remember, under the user data, I have written one script. That script means you are adding some softwares to this particular machine. Ultimately, when this machine is going to boot up, you're going to install, like we were installing PHP, Apache service, PHP, and MySQL. So here, when you are modifying this AMI, like when you are modifying this AMI using that user script, that becomes a modified AMI, and using that you are creating a EC2 instance. So ultimately, these things, the script which you are running, it is adding values to the operating system, and we all know this AMI is a, like it is an image of an operating system. So it's going to add. Suppose I'm going to install PHP, SQL, Apache, then I'm going to get the application from S3 bucket, going to install the application, going to then start the Apache service. So everything is now configured inside the AMI. So now what you can do, guys, you can, like since this EC2 is now running, now you can just create a new AMI. Like you can just like with that particular instance, you can just like create a AMI of that particular instance. There's option to create a AMI of a particular instance. So whatever configurations are there of that instance will be copied to that new AMI. So there's an option to create an AMI. So suppose in that instance, in the last lab, we have installed PHP, MySQL, Apache. Then we have installed the application, a PHP application from S3. Then we have started the service. So that will be configured inside the AMI. So just create a new AMI, AMI using that EC2 machine. We have an option. We're going to do this as a part of lab. Just understand the process now. So once you will create that AMI, then that AMI is a new AMI, and that AMI is created by you. So you can find that AMI inside the My AMI tab. Now you also have the facility to copy this AMI to another region. So there are few steps. With the help of that, you can copy that AMI to another region. Look at this. Initially, we were in region A, where we have launched this AWS EC2 machine using this base AMI. So when we were launching, we have run some user script. Now that OS got updated, it also got few more software installed and some, it also got some, application code as well. So now we have created one AMI from that EC2 machine. So that is your AMI now, because that is a custom AMI, because that AMI you have created. Okay. Now that AMI is stored inside the my AMI, and the same AMI you can also copy to another region. Suppose, for example, you want to launch the same kind of a EC2 machine into another region. So, why to run these commands again and again? You can do one thing. You can copy this image to another region, because AMI are only, like AMI belongs to a single region. So that's why if you want the same kind of a AMI in another region, like a region B, where you want to create machine from that AMI, then you have to copy that AMI to from region A to region B. And then using that region B AMI, you can create a EC2 machine which will be exactly the same, the identical machine as your region A machine, because it is having the same configuration. That's how you can create your own AMI, and you can copy the AMI to another region. We're going to see this. We're going to do the hand-on of this in the lab. Okay. You understood now with the example what is AMI, what are my AMIs which are created by you, and how how you, once the EC2 instance is running, then you can create a AMI from that EC2 instance. You're going to create a copy of AMI, and that will be your AMI, and you can also copy that particular AMI from one region to another region, and then with the help of that AMI you can launch n number of instances. Okay, so this is done. Now let's move to the second component of your the second component of your the configuration of your EC2 machine. So that now you have to select an instance type. So if you remember, after selecting the AMI, I have to select the instance type, where I have selected T2.micro. So it is telling, consider your use case. How will the EC2 instance you create to be used? So based on your application requirement, you have to choose the instance type. So there are different categories of instance type are there. These instance types are choose using these properties, like how much RAM you want for your machine, how much CPU you require, what kind of a storage is required, and what kind of a network performance are required. So suppose if I'm choosing T2.micro, which is having 1 GB of memory, one CPU, one VPC virtual CPU. It supports elastic block storage. Storage we're going to learn in coming module. Okay. So I'm just giving you the example of each and every configuration. And the network configuration is like 1 GB per second speed is going to support. So these are the properties. Based on that, these instance types are defined. So we have 270 plus instance types supported on AWS platform, and these all are differentiating with the help of these properties. Maybe some instances having memory as 2 GB, other instance type is having memory as 3 GB, 4 GB, 1 GB. Same way, processing power, 1 VPCU, 2 VPCU. This type, some are supporting instance store, some are supporting block storage, the type of storages, and some are having different kind of a network performance. So when we're clubbing everything, we are having 270 plus instance types on your EC2 AWS platform. So you can select those instance type based on your requirement. Now we have these instance types, these 270 instance types are segregated into like different categories, guys. So we have few categories like general purpose, compute optimized, memory optimized, storage optimized, and finally accelerated computing. So guys, let me give you a little overview of these categories. So as the name says, general purpose. So general purpose means the what it is having a average power, average CPU, memory, disk space, this is storage option and network performance, which is suitable for doing multiple tasks. So where for the real time, where you can use this general purpose instance, you can use it for creating your web servers. You can use for creating your different software deployment environment. Whenever we create the software, we have different deployment environment like test environment, development environment, production environment. For that also you can create, guys. So general purpose means for generally for all the tasks, because the properties, the configuration of general purpose instance types are average. They're having that kind of a configuration which supports multiple, a broad range of tasks. Okay. The second one is your compute optimized. Suppose like you have some task like video and encoding, or suppose you have created a multiplayer gaming server that requires a lot of compute, because here you need CPU. Like the focus is on CPU. You should have more power, more processing power is required for doing a video encoding task, for creating a multiplayer like a multiplayer gaming server. So they are required these compute optimized servers where you are having you are getting an additional compute power, a high compute power. Okay. Now coming to the third part, that is your memory optimized. So the memory optimized, this your memory optimized instance types are those, okay, which where you need additional memory, additional RAM to perform some tasks. There are some data mining or data analytics, a task are there. Or suppose if you want to create a high performance database, because high performance database requires high memory. Suppose if you want like a high performance database means lot of input output operations per second. Like maybe suppose 1 lakh IOPS per second. That requires a lot of memory. So for that kind of a task where data mining is there, data analytics is there, that requires more memory. The focus is on memory. So for that we are going to use memory optimized instance. Next we have storage optimized instance. So storage optimized instance are those where we need higher storage, where the focus is on storage. For example, suppose we are using some data warehouse application, or suppose we are using some big data kind of application where we need a fast storage and advanced storage is required, which is an optimized storage where the focus is on storage. That's where we use storage optimized instance type. And finally, we have accelerated computing. Accelerated computing means advanced computing. So this machine learning task, if you are having any machine learning application which requires an advanced computing, a higher configuration of computing, for that we can use accelerated computing. So these are the different categories of instance type. We are going to see more details about these categories in the coming slides. After that, the last point of the day is instance type offers family, generation, and size. As I'm telling you, there are 275 instance types. So these instance types are of certain families, of certain generation, and of certain size. So I'm going to tell you like T2.micro is an example of one instance type. So what is this T2.micro? How to identify this? That I'm going to tell you in tomorrow, okay? Because it's already 9 o'clock. So we're going to wrap up this session, guys, today. So I'm going to just give you this form, okay? Just fill this form. Any questions are welcome. You can ask me the question. We'll be here for another, minute. So you can ask me the question, and please fill this form, which I put in the chat. You can ask me the question now, and you can take the form from the chat. So we're going to end the class here. Okay. So now you can ask the question. I'm going to wait for another few minutes to answer your queries. And guys, please perform the lab. Who have not completed the lab, please perform. It's my request. Otherwise, once you will go to the topics, it will be different. So customized instance as well as ready-made instances also. Yeah, both are available. Not ready-made instances, Hital. You are a bit confused. Instances we are creating with AMI. You should ask me customized, AMIs and ready-made AMIs. Customized AMIs are those which you are customizing based on your requirement. Okay, Hital. Any other question, guys? No problem. It's okay. Guys, any other question? It's in real-time requirement of the instance we have to decide, or developer? No. Infra guys will decide. In what we do generally, once the application will be there, we will take some like general purpose kind of an instance we will use. Then we will see how the application is going to perform. We are going to do like stress testing, load testing, multiple things are done in the testing. Based on that, we will see how the resources are getting exhausted, and based on that, we are going to either we're going to increase the instance type, or we're going to downsize downsize your downsize your what is it that type downsize your instance type based on the testing. Initially, we started with general purpose. Then, based on the testing, we decide whether we have to increase, what kind of a component, what kind of a property we have to increase of instance. It is entirely decided by infrastructure team, not developers. When you copy paste the DNS link, load error messages come in. Okay, no problem. Then you do one thing. Okay, just do are you able to get the website through that Chandeep? Are you able to get the website through that public IP? I think DNS link won't work. Yeah, we can get it from public IP. Are you getting from public IP? 11. I can't get the lab host. You will get the lab host, Surinder, because you are not in the correct region. Check out. I think you would be in the Oregon region. Just check out. Surinder, you can check out the region. You would not be in the North region. Please come back to the North region and you will get the lab host. Okay. Any other thing? Because it's already Sandeep, have you tried? Just try it. You will get the response from that web server. Oh, no problem. So in that, please try. That is the only reason, because you're not in the correct region. That's why you're not going to see that. And Sandeep, you can also try, and you definitely will get the response. If you're not getting the response, that means you have not created that VPC correctly. You have to check all the steps again. Okay, guys. So I think I've answered all the queries. So let me wrap up this class now. And Sandeep, tomorrow just tell me whether you're getting response or not. Okay. Okay, guys. So let's wrap up this class. Thank you so much for joining this class today. Please revise all the concepts. We're going to see each other tomorrow. And please perform the labs and activity if you're not done. And revise the concept. That's what I have to say. Thank you so much. I'll see you tomorrow. Good night. Bye.